Hi, so the purpose of this video is to clarify how the critical values are found, right? So this table right here, and you can use these values, right, for calculating the confidence interval, right, of a proportion for section 7.1. Now, these are the values of z alpha over 2 for some of the most common confidence intervals, right? And you can see that as your confidence level, right, increases, so does the critical value, right? And just remember, this is the formula you use them in, right? Excuse me. Okay, so if you think about it, right, for a confidence interval of a particular percent, you want to have like a certain percent probability that you are inside that confidence interval. So since there's a normal distribution here, right, you're trying to figure out what's this value, right, that cuts off, right, whatever my percentage is, right? So I would either want 0.95% or 95% of my area to be in the center, and then hence 0.025% to be on both of the wings, right, etc., right? Or it could be, right, whatever it is. It could be that you have 99% here, and then you have a 0.5% in each wing, right? So you need to figure out what z-score, right, cuts that off. Okay, so let's show you an example of how you would find it, right? So let's think about this, right? And these are the values that we'll get. I want my confidence interval to be 95%. So I want this area here to be 0.95, right? So that means in the two wings, I have 0.05 or 5%. Divide that by half, I know that I have 0.025 in each of the wings. Okay, now I can use this table, right, the original z table to figure this out. But you have to remember, right, when you're looking at this table represents area to the left of the z-score. So I want to find these two z's, so I'm really kind of finding two z-scores. The negative and the positive one, between which is 95% of the area. Well, if 95% of the area is between them, right, and my table represents area to the left, right, the z value, I want to find what's this z value. Well, it's the z value, right? Now add these together. So the z value with, well, 95% and then another 2.5% right there, right? So a z value with 97.5% to the left. All right, so I want to look at the positive 5. I'm looking for the number that's closest to 97.5, which is, well, not exactly, but it's exactly as it is right here. So notice this is AZ alpha over 2 of 1.96. So that Z is 1.96. Which is this value right here. Now it's good to write these values down, like on your notes for the next celebration and whatnot, right? And that would be great. But, you know, so these are the most commonly used z alpha over 2 values, so you don't have to find them each time, right? But it would be nice to be able to find them. Maybe I ask you to do like a weird confidence interval, something like 97%, or maybe 98%, something like that, right? Now, but before we try a different one, let's also talk about this, right? If I instead want not to use the table, but I use my calculator, I could type into my calculator invert norm, and then the percent of the area, the portion of the area I want to the left, which in this case would be 0.975, because I want 95% of the area to be in the middle, which means that I have to combine that area with the area on the left. So let's do our own one, right? So let's say, what is Z alpha over 2, our critical value, for a confidence level, that's the confidence level I want, of, right, if I said confidence interval before, I meant confidence level, right, of 98%. Okay, well, let's just draw that out. So I want 98% in the middle. That means there's 2% to go between the wings, right? And since it's symmetric, half of it will be in each wing. So 0.101, or 1% in each wing, right? And then remember, again, our table only finds values to the left of the z-score. So I want to find what's this z-score right here that cuts off. It's going to cut off 99% of the area. So I want to look for in the table .99. And you look there, you're not going to quite have that exactly, but these two are very close. So it's between. So then I can estimate, right, in this case, Z alpha over 2 will be about 2.3. Now, 2.32 is not quite enough. 2.33 is a little bit too much, so I can do 2.325, right, to split this difference right here. If I wanted to know it exactly, or as exact as you want it to be, I could type invert norm 0.99 into my calculator to give me the exact z-score to help me find a comp for that particular confidence level. Okay, so that is the answer to the question that was asked.